Okay, this is first problem of the test review, and this will be problem one. And these problems are review problems from things we've done before. So professional golfer John Daly is known for his long drives off the tee. Suppose his drives have a mean of 295 and a standard deviation of 27. So mu equals 295, standard deviation is 27. The shortest 7% of the drives will be shorter than what? So since we're working with an app and since they gave us a percent, that means we're going to be working with an inverse norm. Remember, if they give you the app, it's an inverse norm. So this would be an inverse norm. And we need to draw a picture, but first we need to figure out where this is. So anytime we have one of these like this, where it's shorter than or longer than, it really helps if we just take a moment and we put an X down. So here's my X. Well, 7%, is it going to be more than? No, it's going to be shorter than. So 7% is below it. So this is going to be a less than. So we're going to be shading from the left going up. So here we go. Here's our picture. And our picture looks like this. Well, this area is 0.07. That's my area. So they gave you the area, they gave you the app, and we have a mean of 295. So when I do this problem, it's going to be a second vars inverse norm. And we're going to go to the calculator. Second vars inverse norm. And they asked for the area first, which in this case, our area is just plain old 0.07 because we started at the left. When we have a mean, and our mean is 295. And then we have our standard deviation of 27. So 0.07, mean of 295. Standard deviation of 27. And we end up getting a value of equaling 255.1536 because we're going to go 4 decimal places and truncate. Now, please remember, does that make sense? And it's like, oh, this is the halfway point at 50% and 255 is below it. So from a logical sense, it makes sense that it would be less. So this is my answer for the first problem. 90% of his drives will be greater than what length? So once again, we have a direction with a percentage. So 90% will be greater than what? So 90% are greater, so 90% will be above. All right. So this is this direction, just like this, which means we're coming, the 90% is up here, so we're coming from the right. Once again, our mean is still 295. Draw my picture. My mean is still 295. But we're coming this way, and we need 90%. So we're going to cross over. And this area here is 0.90. And I'm going to need this area, which is 1 minus 0.90, which is 0.10. And remember, the calculator is working left to right. Once again, they gave me a percent. If they give you the app, it's inverse norm. So once we have inverse norm. Our area from left to right is 0.10. Our mean is still 295. And our standard deviation is still 27. So when I go to the calculator with this, second vars, inverse norm, area 0.1, mean of 295, standard deviation 27, and we end up getting 260.3981. Well, that's less than the 295, and it makes sense because we know it's going to be below that. But this was 7% and this is 10%, so we would expect this number to be a little bit larger than the last one. Now, the next one, we have a couple different ways of approaching this, and I'm going to look at it 2 different ways, and you can choose which one you want. It says what z-scores are associated with the middle 60%. All right, so what z-scores are associated with the middle 60%? That means we're centered on the mean, and I have 0.60 right here, and we're centered on this 295. And I'm going to be looking for a lower bound and an upper bound. I'm going to be looking for two values. Once again, they gave me an app. If they give you an app, you're going to have to use inverse norm. So we're going to be inverse norm. But this time, we have 1 minus the 0.60, all of this in parentheses, divided by 2. That's my area when we're working with a left and right. Mean of 295 and standard deviation of 27. So that value hasn't changed. So when I go about doing that, the second vars, inverse norm, parentheses, 1 minus 0.60, close the parentheses, divided by 2, mean of 295, 27. And this gets me the lower bound. All right, so my lower bound, oops, I'm sorry. I'm wrong about that. I made an error because it didn't ask for the actual values, it asked for the z-scores. And the z-score always has a mean of 0 and a standard deviation of 1. Sorry about that. So second vars, inverse norm, mean of 0, standard deviation of 1. And I end up getting negative, my lower bound is negative 0.8416. And my upper bound is 0.8416 by symmetry. Now, there is another way to do this, and it may be easier for you now that you've learned how to do confidence intervals. So try this out. You may like this better. We can go stat, test, and we can drop down to number 7, which is z-interval. All right, so if we go z-interval, and we plug in standard deviation for all z-scores is 1. The x bar for their mean is going to be 0. N, because they didn't give us a sample size, is 1. We want a confidence level of 0.60. So I don't know if you'll like this better or not, but if you go this route, this will be the work shown. So second vars, excuse me, stat, test, number 7. And I have standard deviation of 0, excuse me, standard deviation of 1, mean of 0, and a n of 1. And because we're working with z's, when we're calculating z's, this will always be the case, 101 every single time. So 101, but then we need to plug in our confidence level, which is 0.60. And press enter, and there we go. We get the same negative 0.8416 and 0.8416. And so once again, 101, and then our confidence level of 0.60. The next thing, it says what drives will constitute the middle 60%. So here we were z-scores, and now we want the actual drives. So now we're no longer centered on a mean of 0. Up here, we're centered on a mean of 0. Now we actually are going to be centered on that mean of 295. So we're actually going to have a mean of 295. We're still going to be looking for a lower bound and then an upper bound. All right. Here we definitely want to use the z-interval. All right. So we're definitely going to want to use our z-interval. And we're going to need the standard deviation, which in this case was 27. We're going to have an x bar of 295. They didn't give us a sample size, so since they didn't, we'll use an n of 1. And we're going to use the confidence level equal to 0.60 because they wanted 60%. So let's try that out. So stat, test, I'm going to scroll down to number 7, which is z-interval. My standard deviation was 27. My mean was 295. We said they didn't give us a sample size. When they don't, we're going to use 1. And we keep the confidence level of 0.60. Oops. Hate it when I hit a button. And so now I get a lower bound of 272.28. That's my lower. And I get an upper bound of 317.72. And that's my upper bound. So the next thing says, what are the z-scores associated with the middle 94%? So we're looking for a z-score. And anytime we're looking for a z-score, we know that our mean is 0. So we're going to be centered on 0. And we have a mean of 0.94. And we have a lower bound and an upper bound. And I'm going to go ahead and do this as a z-interval route just because I think it's easier. So with the z-interval route, the standard deviation is 1, the mean is 0, and n is 1. This will always be for a z. When we're working with a z, it's 1, 0, 1 every single time. All right? And then we have a confidence level equal to 0.94. So let's try this one out. So stat, arrow over the word test. And we want number 7 for z interval. Our standard deviation is 1. Our mean is 0 because we're centered on 0. We don't have a sample size, so we're using 1. We want the confidence level to be at 0.94. So we end up getting negative 1.881 and 1.8808. So negative 1.881 is our lower, and our upper is 1.8808. And by the way, if you will notice, 0 is right in the middle here, and that's what it shows here, because this is our lower, negative 1.881 and positive 1.8808, and 0 is in the middle. Then the last one asks for what lengths of drives will constitute the middle 94% of his drives. So now we're looking for the middle 94% of his actual drives. So we're still working with like a confidence interval. We have a lower and upper, but instead of being centered on 0, we're going to be centered on 295. We're still going to be working with a z interval. So we're going to have a standard deviation, and we're going to, since we're using actual values, the actual drives, our standard deviation is 27. Our mean was 295. We didn't have a sample size, so we used 1. And we're using a confidence level of 0.94 because that's what they asked for. So here we go. We're going to rerun this thing. Stat, arrow over to test, drop down to number 7 for z interval. Our standard deviation is 27. Our mean is 295. Our sample size is 1, and our confidence level we can leave at the 0.94. And we get 244.22 and 345, and that 295 is right in the middle. 244 is below it, 345 is above it, so that looks pretty good to me. So we're going to write that down. 244.22 and 345.78. This is my lower, and this is my upper. Okay, so that's my lower, that's my upper for letter F. Number 2, the annual shares of employees in a large company are approximately normally distributed with a mean of 55,000 and a standard deviation of 20,000. So I'm going to go ahead and make that note a mu of 55,000, and a standard deviation of 20,000. What percent of people earn less than 40,000? So now they're asking for an app. They're asking for a percent. And since they are, I can use a norm CDF. But we need to draw a picture of this. And the picture looks something like this with a mean of 55,000. Now we want less than 40,000. So I'm going to put the 40,000 right here, 40,000. And they say less, so I need to shade this direction. And don't forget that this graph goes from negative infinity to positive infinity. And so we already, since they're asking for a percent, they're asking for the app. It's a norm CDF, lower bound, negative infinity, upper bound, 40,000, mean, our mean is 55,000, and our standard deviation is 20,000. So let's go ahead and enter that. Negative infinity to an upper bound of 40, 1, 2, 3, 40,000. A mean of 55, 1, 2, 3, 55,000, and a standard deviation of 20,000. I guess I probably should put a bunch of negative nines because that's what we're used to working with. When I do that, I end up getting 0.2266 is my answer. All right. The next one, what percent of people earn between 45,000 and 65,000? All right. So we still have the same mean. We still have the same mean of 55,000. So we're centered on 55,000. But we want to know what people earn between 45 and 65. Well, 45 is below it. So I'm going to label this 45,000. And 65,000 is above it. So I'm going to label that here. And we want to know how many people earn in this range. Well, again, they asked for a percent. So they asked for the app. They asked for the app. They asked for the percent. And remember, percent is area, percent, and probability. If they ask for it, norm CDF. So I have a norm CDF. My lower bound is 45,000. My upper bound is 65,000. My mean is 55,000. And my standard deviation is 20,000. So here we go. Second vars, norm CDF, lower bound 45,000, upper bound 65,000. I want to make sure I have the right number of zeros. I do not. So I got to go back and clear these out. 45, 1, 2, 3, 65, 1, 2, 3. And then I have my 55,000 and 20,000. 55,000 for the mean, 20,000 for the standard deviation. That didn't change. And I end up having that 0.3829 of the population earns in that range. The next one, what percent of the people earn more than 70,000? Well, our mean is 55,000. This right here is 70,000. And they're asking for an app. They're asking for one of the, remember area, percent, of probability. They're asking for it. And since they're asking for it, it's a norm CDF. My lower bound happens to be 70,000. My upper bound is positive infinity, because don't forget these go to positive infinity and negative infinity. Guess I should label that up here as well. My mean is 55,000, and my standard deviation is still that 20,000. All right, so here we go to the calculator. Second vars, norm, CDF, lower bound, 70,000. 7123. Upper bound, we're going to load this up with a bunch of nines because this is going to infinity. Mean is still 55,000, standard deviation is 20,000, and we end up getting 0.2266. Out of a population of 73,647, how many people earn more than 100,000? Well, this is a complicated problem. First off, we need to figure out what percent of the people earn $100,000. So let's find out how many people earn $100,000. So when I do that, we still have a mean of 55,000, but we're going to go all the way up to 100,000, and we're looking for this area, and it says more, so we're going to shade all the way to positive infinity. In this case, because I'm looking for this area, I'm looking for an area, I'm looking for a percent first. This needs to be a norm CDF because they asked for the app, an area, percent, or probability. They asked for the app. The lower bound is 100,000. The upper bound, positive infinity. The mean is 55,000. And the standard deviation is 20,000. So let's do that. Second vars, norm, CDF. So I'm going to change that 70,000, the lower bound, to 100,000. 100, 1, 2, 3. And then I already have the positive infinity in, I already have the mean in, the standard deviation. And I end up getting a probability, the probability that one individual earns this much money is that. All right, about 12% or about 1.2% of the people earn over $100,000. But out of 73,647, how many earn that? So now we're looking for how many do you expect to earn, which is NP, which in this case is going to be 73,647 times 0.0122. And I'm just going to use the numbers in a calculator, so please don't truncate around and write down exactly what I put in, times 73,647. And that equals 900 people. So we're going to just make that our nice whole number this time. 900.2928 is what I get. Please put it into 4 decimal places, just what I have, into your answer. Then it says, given a random sample of 30 employees, what's the probability the average earnings is at least $661,000? So they asked for the average. So they asked for the X bar, and we have a sample size of 31. So this is going to be a little bit different. All right. So once again, our mean is still 55,000. But instead of a singular value, we have an average, and our average is up here at 61,000. So this is an X bar. And so we're going to need to use a Z test this time. All right. All right. We could do it with a norm CDF, but it's going to be easier with a Z test. So we're going to go stats test, Z test. And the first thing it's going to ask for is our mean. Well, our mean is simply 55,000. The next thing it's going to ask for is our standard deviation, which is 27. The next thing it's going to ask for is our X bar, which in this case is 61,000. Excuse me, this is not correct. This is not 27. This is $20,000. We're still working with that $20,000 problem. Sorry about that. And we have an N of 31. So let's go ahead and enter that information. So stats test, Z test, my mean, well, what were they earning? On average, the population earns 55,000. The standard deviation is 20. The X bar is 61,000. Our sample size was 31. And we shaded up because it says at least 61,000, so 61,000 or more. And when we calculate this, we end up getting the probability that Z is greater than 1.6703 equals 0.0474. And I probably should have written this down, so I'm going to do this. A probability that Z is greater than 61,000 minus the 55,000 over the 20,000 divided by the square root of 31. That's the formula we were using, or that's the equation. And our actual formula for this one was simply Z equals X bar minus mu over sigma divided by the square root of N. All right. So, and by the way, this was a Z test, okay, versus something the norm CDFs that we used on the other one. All right, that'll conclude this video. The next video will cover problem 3.